So chapter 4 is going to mainly be dealing with tessellations. Tessellations of some shape or form. So our first tessellation that we're going to be looking at is going to be moving it up, down, left, or right. And the way that we talk about moving a shape or line or point is by a vector. A vector is a line or a ray with both size and magnitude. A vector is a quantity that has both direction and magnitude, or we kind of talk about it as size. So I believe everybody in this room everybody knows what a vector is, yes? You know what a vector is before this?
Despicable Me.
Yeah, Despicable Me. Despicable Me, actually, one of the villains in Despicable Me is Vector. Vector because it has both magnitude and direction. That's how we define a vector. Yeah. Yeah, it actually defines what a vector is. And we use it in geometry to kind of tell how something is moving in both direction, up, down, left, or right, north, south, east, or west, and magnitude, how far it's moving. Now, when we write a vector, we're going to start with the initial point and the terminal point. The initial point is where it starts, the terminal point is where it finishes. So for the vector that they gave, PQ, well, the initial point where it started is point P, the terminal point is point Q. So we'll name it as PQ with an arrow or a ray starting at P and pointing towards Q. Now the component form is with these kind of two arrow brackets. The first number is dealing with the X, the second number is with the Y. Now this is going to make a little bit more sense when we actually look at an example. So slope is rise over run. And slope is written as a fraction. So it'd be something like this here. So it would be similar to slope, but they're not the exact same thing. But they'd be similar, because slope is going to be a number. Vector is going to be in two spots. So we look at this, when we name it, we're going to need the 2 points. So we'll need J and K. Initial always goes first. So our initial point for this vector is going to be point, what? J, and it goes to K. Because it starts at J as its initial, its terminal point is K. So we have JK. And we draw the line going from the arrow, or ray, going from J to K. So that's how we can name it. Now its component form. So we're going to have these two kind of arrow brackets with a comma in the middle. Now the first number is going to be the change in X. So if we're going to the right, it's going to be positive. If we're going to the left, it's going to be negative. So let's see how far it moves. Well, it goes over 1, 2, and 3. It's going to move 3 units to the right. So it would be positive or negative 3. It's going to be positive 3 because it's moving to the right. Right is going to be positive, left is going to be negative. And where does it go from there? Up 4. 1, 2, 3, 4. And since we're going up, it would also be positive 4. So the name for this vector would be JK, with our ray going from J to K. And the component form would be 3, 4. And that's it. Questions on this here? Let's look at the next one. So we're given this here. We've got a point P and a point Q, and we have our vector. So if we name it, our initial point would be what? Terminal point would be Q, and it's going from P to Q. So P to Q, and our line goes from P to Q. One, two, three, four. Yes. It would be -4 because it does move 4 horizontally. And because it's moving to the left, it would be negative. And then from here we go up. 1, 2, 3, 4, 5. It's -4, 5. Because we're moving up, it's positive. And since we move to the left, it would be negative. Any questions on any of this here? Are we good with this here so far? Are we ready for the next one? Yes? Okay, let's look at the next one. Name the vector and write its component form. So we have B and K. So the initial point would be B, and our terminal point would be K. And it's going from B to K. Now, horizontally, how far did it move? -5. You moved 5 units into the left. And then up 2. Since it moved to the left 5, it would be -5. And since it moved up 2, it would be a +2. Any questions on this here? Any question over anything we've done so far? Okay. We can use this with shapes, with geometric shapes, because our translations, what we're talking about first, is moving every point of a figure in the same direction and same distance. More specifically, a translation maps or moves the points P and Q of a plane along a figure, along a vector A, comma B to the point P prime and Q prime, so that one of the following statements is true. So really, we're moving it to its new spot, and whatever we move it, we call it prime. So if I move point A for this triangle here, its new position, we would call it A prime. The new point would be A prime. And we can continue on, because if I moved it again, it wouldn't be A prime, it would be A prime prime. Because we can keep adding a prime for each new spot. Now, if I look at this here, we're given a triangle. So y'all are given this here, yes? A is at 0, 3. So A is here. B is at 2, 4. And C is at 1, 0. Now, how do we move it? How is this being moved? Along the vector 5, -1, yes? Because it's being moved along that, right? Well, the 5 is telling me what? To the left or to the... And the -1 is telling me up or down, yes? Since the 5 is positive, it means it's moving 5 units to the right. And the -1 is telling me it's moving 1 unit down. So each and every single one of these points are going to move 5 to the right and down 1. So if I start out at point A, well, it would go 1, 2, 3, 4, 5, and down 1, getting me A prime. It'd move 5 to the right and down 1. We can do the same thing with B. It would move 1, 2, 3, 4, 5, and down 1. And finally, C would move 1, 2, 3, 4, 5, and down 1 to give me C prime. Questions on this here? Now we can connect those dots. And if we do, we'll get our new shape, our new triangle. Triangle A prime, B prime, C prime. That's it. That's all we have to do. Questions on this here? The vertices of ABC are 0, 3, 2, 4, and 1, 0. Translate the triangle using the vector -1, -2. Good. A, B, and C. So the -1 is telling me what? Where is it moving? Would be left 1. The -2 is telling me it's moving where? Down 2. So all of these points are going to go left 1 and down 2. So I can start off with A. So I'm going to go left 1 and down 1, 2. B is going to go left 1 and down 1, 2. C is going to go left 1 and down 2. So we get A prime, B prime, and C prime. So left 1 and down 1. That's it. Questions on these here? Questions on any of these here so far? Could we have done this algebraically? Because let's think about the point. Let's say the point 0, 3. So when I move it to the left, I'm really what? Subtracting 1 from the x value? Yes? So I could say what? 0 minus 1. And we'd have what? 3 minus 2, yes? Well, 0 minus 1 would be -1. 3 minus 2 would be 1, yes? -1, 1. Is that where A ended up? Because this was A. Is that where our A prime ended up being? Yeah. We can do this mathematically. We can do these movements to each point. We can apply it to the numbers. All right. Let's do another one. They gave us this shape, this triangle, LMN. Translate LMN using the vector -2, 6. Well, yeah. So the vector tells me I have -2 and 6. So the -2 tells me what? It's moving to the left. How far? 2. And the 6 tells me it's moving 6. So each one of these points, so L is going to go to the left 2, 1, 2, and up 1, 2, 3, 4, 5, 6. And I get my point. M is going to the left 2, 1, 2, and up 1, 2, 3, 4, 5, 6. And lastly, N is going to go 1, 2 to the left and up 1, 2, 3, 4, 5, 6. Which gives us our brand new shape. After we did the translation of -2, 6. Any questions on any of this here? Are we good with this here? Yes? Okay. Let's write a rule. Now that we've been comfortable and we've gotten comfortable with moving the shape by a vector, let's actually write a rule for it. And we write a rule, well, kind of as we've been working, we've been dealing with vectors. So if I want to describe how something moves, I'm going to use a vector. Now, which one would be the starting point? The blue. The one where I have A, B, and C. Because the one in red has that little, what is that? prime, because it's A prime, B prime, and C prime. Because we talk about it in English as an apostrophe. But for math, we'd say that's prime. A prime, B prime, and C prime. Because whenever we add the prime, it is our new spot. It's our new location. So that means I'm going from this point here from A up here to the new spot. So from here, we went over 1, 2, 3, 4 spots, yes? So our horizontal, our movement along the x would be 4. Now, would it be positive or negative? Negative, because we're moving to the left. And then where do we go from here? We went up 1. And the 1 would be positive because we're going up. And that's it. We wrote a rule. We wrote a rule for it. Any questions on this here? Are we good with this here? Yes? Let's look at the next one. So again, we can look at any of these points, but again, I'm looking for A, B, and C. I'm not looking for the one that has the prime, because prime is the new spot. So we're trying to see how it goes from C to C prime. And we're going to write it as a vector. Now, how far did it go to the left or to the right? 2. To the right or left? So since it went to the right, the 2 would be positive. How far did it go up or down? It'd be negative 1 because we went down. That's it. That's it. Now, as we talked about this here a minute ago, we can use this notation here to also signify a vector. Because this here, so x comma y, translated to x plus 3 comma y minus 1 is the same as the vector 3, negative 1. It's doing the same thing. And really what this is saying, so let me get a highlighter. What this here is saying is that each x value we're doing what? We're adding 3. If we're adding 3, we're moving it which direction, left or right? Right, 3 units, yes? The minus 1 is telling me I'm moving up or down 1 unit. I'm moving down 1 because we're subtracting 1. And we can do this with each point. I'll do it with A. So if I used A in this here, well, it'd say negative 1, 2 is being translated. Well, we'd have negative 1 plus 3 comma 2 minus 1. I just plugged in xy because my xy value was negative 1, 2. So we translated to x plus 3 comma y minus 1. X was negative 1, so negative 1 plus 3 comma 2 minus 1. Well, negative 1 plus 3 would be 2. 2 minus 1 would be 1. So our new A value, negative 1, 2, which was down here, is now at 2, 1. Here's our A prime. Any questions on this here? Okay, well, let's do it again. Let's do it with B. So if I do this with B, negative 1, 5, well, this would be negative 1 plus 3, comma 5 minus 1. Well, negative 1 plus 3 would be 2, comma 5 minus 1 is 4. So our B went from here and now is at 2, 4. really, what am I doing to each one of these? We went right 3 and down 1. And we could do this mathematically again and again. Or I can take this and go 1, 2, 3 and down 1. From C to C prime. Say for this here, 1, 2, 3 and down. Or I could have gone 1, 2, 3 and down 1. But unfortunately, y'all can't use that trick with just moving the shape itself on your paper. Any questions on this here? Are we good with this here so far? Okay, let's look at one more. Now, if we did this mathematically, I'm going to do 2 points. I'm going to work out 2 points using the math, and then we can use our other methods for the rest. So I'll use this using A and B, 1, -2, and 2, 1. Now what it's saying is we're taking an xy, so 1 and -2, and that's going to become x minus 1. So we'd have 1 minus 1, comma, y plus 4. So our y value is -2, so we'd have -2 plus 4. Well, 1 minus 1 is 0. -2 plus 4 is 2. So our A prime, our new A location after we did this translation is at 0, 2. Now we can do the same thing with B. So we'd have 2 minus 1 for our x, and then we'd have 1 plus 4 for y. Well, 2 minus 1 is 1. 1 plus 4 is 5. And we have these 2 points here, and we could have graphed each one as we found them. So 0, 2, and 1, 5. What do we know about this here? Because we have x minus 1, we're moving it horizontally how far? 1 into the left because it's negative. Since we have y plus 4, it's telling us that we're moving up 4. So for C at 4, 1, I could have moved it left 1 and up 1, 2, 3, 4, which would have given us C prime. And the same for D. We would have moved left 1 and up 1, 2, 3, 4, which would have gotten us D prime. So left 1 and up 1, 2, 3, 4. We get this new figure here. Any questions on any of this here? Are we good with this here? Yes? Do we feel comfortable with this here so far? Yes? Okay. I mean, if we wanted to, we could do this with the points, but really what is this moving? The x plus 1 tells me I'm moving right 1. So I can take this triangle and move it right 1 and up 1, 2, R, S, T to our R prime, S prime, and T prime. And that's all we have to do for this here. Any questions on any of this here so far? Are we good with all this here? Yes? a rigid motion, and what we've been doing is a rigid motion because it preserves lengths and angle measures. We're not changing the shape. Because all the shapes that we had are the exact same as what we started with, yes? Our new shape and the original shape did not change in size or shape. They were congruent. Another name for a rigid motion is isometry. A rigid map, lines to lines, rays to rays, segments to segments. The translation postulate states a translation is a rigid motion. It doesn't change. We also have a composition of translations. The composition theorem, the composition of two or more rigid motion is a rigid motion. So we can do more than one of these. We can do 2, 3, 4, 7, 20. It doesn't matter how many. We can do multiple rigid motions together. And that's what we're going to look at last. We're going to do a combination of these motions. And we're going to look at it with this line here, this line segment, RS. And you're going to have to do this on the homework assignment, and we're going to do them in order. Now, the first translation is this here. XY is going to x plus 5, comma y minus 2. So if I looked at our 8, 5, so we're going to have x plus 5. So we would have negative 8 plus 5, comma, y minus 2. Well, that would be 5 minus 2. So the first one plus 5, so we're moving 5 units to the right. Our minus 2 would mean we're moving 2 units down. Well, negative 8 plus 5 would be negative 3. Because negative 8 plus 5 is negative 3. 5 minus 2 would give me 3. So our R is now at R prime at negative 3, 3. And we can graph that point. Negative 3, 3. This here is R prime. Let's do the same thing with S. So with S, we're using the point negative 6, comma 8. We're adding 5 to the x and subtracting 2 from the y. Now, negative 6 plus 5 is going to be negative 1. 8 minus 2 is 6. So S prime is at negative 1, 6. Any questions on how we translated the line segment RS to R prime S prime? Are we good with this here? Yes? Now we're translating R prime S prime because we're translating that point to our next one using this one here. So to do the second one, we're now subtracting 4 from x and 2 from y. Really, we're moving it to the left 4 and down 2. So we'd have negative 3 minus 4 and 3 minus 2. Well, negative 3 minus 4 would be negative 7. 3 minus 2 would be 1. Now, what would we call this point? Because it'd be R what? Double prime. Because we're going to have another prime. Because each time we move it from R to R prime, R double prime, well, if I move it again, it would be R triple prime. Because we're going to keep adding a prime to it. Any questions on any of this so far? I throw a pin. Now we're going to do the same thing with s prime. This time we're going to subtract 4 from x, so it'll be -1 minus 4. And subtract 2 from y, so it'd be 6 minus 2. Well, -1 minus 4 would be -5. And 6 minus 2 would be 4. And that would be our s double prime. Any questions on any of this here? Any questions on any of this here so far? Huh? Yep. So -7, 1 would be our r double prime. And -5, 4 would be our s double prime. Which gives us this here. So that's our final location. Questions on this here? Any questions on any of this here? And yes, the homework is going to want both lines. It's going to ask for both. Any questions on any of this here? Bless you. Let's look at another one. So we've seen one using the math, using those numbers there. So let's do one with just looking at the movements. So this point here, -8, 5, and -6, 8 is moving what? Well, this would be left 1 and up 4, because the -1 tells me it's moving to the left, and the +4 with y is moving up 4. So at this point here, we'd move left 1 and up 1, 2, 3, 4. And the other one is going to move left 1 and up 1, 2, 3, 4. Well, we've gone clear off the page, yes? Now, luckily for the assignment that you have, this isn't possible. Now, the second movement, +4 with the x, means I'm moving to the right because it's positive, and I'd be moving 4. -6 on the y would be down 6 because it is negative. So from our point here, we would go 1, 2, 3, 4, and down 1, 2, 3, 4, 5, 6. Now this one here ended up 4 above, so it's going to take me 4 to get back to this line here. 5, 6, and we'd go how far? 1, 2, 3, 4. So this was R prime, and R. This is our S prime, and S double prime. Are there any questions on any of this here? Any question of anything we've done so far? Could I have done these exact same double translations or doing multiple translations with just lines? Could we have done it with a figure? Right, we could have done it with a triangle. It doesn't change what we're doing. We're just moving it up, down, left, or right. We're just moving it some combination of those two.